Hello, I welcome you all. The problem reads the jib crane is pin connected at A and supported by a smooth collar at B. Determine the roller placement X of the 5,000 pounds load so that it gives the maximum load, the maximum and minimum reactions at the spots. Calculate these reactions in each case. Neglect the weight of the crane. Require X or the domain is X greater or equal to 4 feet and less than or equal to 10 feet. So this is the range that we are going to consider for X. Right, this problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. So this is our coordinate system that we are going to adopt, X in that direction, positive Y, and the moment anti-clockwise. Right. So let's draw up a free body diagram. We expect to have a reaction there in that direction AY and AX. And also here we expect to have just one reaction because it's free along the y-axis. Therefore, we're only going to have BX. Okay. Right. And we've been taught that the weight, the roller placement X over 5,000 load. So we have a load. This load here is 5,000, right? This is 5,000 pounds, right? So I've been asked to calculate the reactions maximum and minimum based on the range that we've been given. Okay, so to start with, we're going to take moments about A. All right, summation of moments about point A is equal to 0, anti-clockwise being our reference. What we have a minus clockwise minus moment BX times the lever arm 12. Okay, and then we also have another negative moment, which is a 5,000 times X. This is equal to 0. And therefore, our Bx is going to be equal to minus 5,000 X divided by 12. This gives us, if we are to do the calculation, it gives us 5,000 divided by 12, it gives us 416.67x. Right. Let's find what AX is and BX, okay? So summation of forces in the X direction, this being our reference positive. We have AX, so this is minus. But I'll change this for now because I know minus just means the other side, right? So if I was to write this, it's just telling me that the reaction force here is supposed to be in this direction, Bx. Okay. And this C, just a 416.67x. All right. So I'll consider this when I'm writing now. Okay. So AX, okay, I've changed now. I've just changed it based on this result. You've seen this result. I changed this based on this result there. Okay. So don't get confused. You can go with the same assumption if you want to and so on, right? So if I've changed this, therefore it means AX, then this is going to be minus BX, all right? Then it's equal to 0. And therefore, since we've already found what BX is, but we've already changed the direction, okay? Therefore, my AX is going to just be equal to 416.67x. And when you look at this is a linear function. Okay, it's a linear function with a positive gradient of 416.67. Very high gradient. All right, so then let's find summation of forces in the y direction. What we have AY minus 5,000 equal to 0, and our AY is just a constant, which is just 5,000 pounds. So now we've been given this domain of X. So what we're going to do is we're going to show the maximum and the minimum by just doing some plots. We'll plot this on the x, y axis. Okay, so this is going to be our x, which is in feet. Okay, and this is going to be our y. In our case, our y is ax or bx. Okay, and it is in this one is in what units? Pounds. All right, so let's start. So we have been told we are starting at 4, so let's assume this is our 4 feet, and let's assume this point is our 10 feet. All right, so let's start somewhere. So this point here, let's assume these are the 2 points for ax and bx, right? So when x is equal to 4 feet, ax, which is equal to bx, is going to be equal to 416.67 times 4, and this gives us times 4, it gives us 166.67 pounds. Is that so? So we can indicate it here. So we have a 166.67. Okay, right, let me wrap this. So that's a value when x is equal to 4, and then when x is equal to 10 feet, then our ax, which is equal to bx, is going to be equal to 416.67 times 10. Then this gives us ax is equal to bx is just going to be equal to 416 point, okay, because this goes on, I want 2 decimal places. Okay, I'll leave it like that, just at 7. Okay, all right, so let's imagine, let me just reduce this a little bit. This is pounds. All right, so we are here. So this value here is going to be equal to 416.7. Okay, there we go. All right, so we have a linear increase. So from this point to this point, we have this behavior. Okay, let me just use red. We have this behavior, right? Where is my red? Yeah, this. So this is how it can be shown on the graph. So we have a maximum reaction at both B and A in the horizontal direction when the load is placed at x is equal to 10 feet, and it keeps on reducing as we reduce the value of x. So it's been guided by this particular line. Okay, and the function is equal to a, like we already said, is equal to ax, which is also equal to bx. Okay, ax is in this direction, bx is in this direction, is equal to 416.67x. Alright, I guess we are done, and I hope the video was helpful. If it was, give me a thumbs up, like my video, share my video, and bye bye. See you in my next screencast.